let us look at the strength of weak acids. So, I've drawn up two weak acids here. I have acetic acid there, and I have trifluoroacetic acid here. They're very similar to each other, and the names are quite similar. The only difference is that I have 3 fluorines on this carbon, whereas over here I have hydrogens. Now, what does this do to the strength of the acid? Well, in order to answer that question, again, sometimes it's best to look at the stability of the ion that's formed in solution. So in both cases we'll make H+, but then I've drawn the ions that we make, the anions that result from the rest of the molecule down here. And you'll notice they are quite similar. They both have a negative charge right here, and they have this carboxylic acid group. The only difference being that there's this fluorinated group over here. Now, both of these have resonance structures where this negative charge can exist either on this oxygen or on that one, depending on where I put the single bond and double bond. So if I were to switch these positions, I could put the negative charge up here and have this double bond, have a double bond here. That's important to the overall stability of this ion. But that exists over here as well, and that's common among all carboxylic acids. In fact, that's one of the reasons it is an acid, because it has the ability to delocalize that negative charge over 2 atoms instead of just 1. So, that's not explaining the difference between these two acids. What is the difference accounted by is this fluorine group right here. So this is stronger than that acid. And the reason why is that this group right here is pulling electrons away. It will pull electron density towards it, which will help stabilize this negative charge over here. So part of this charge will end up over here because this is going to pull the electron density towards it. Whereas over here, this is actually an electron donating group. So it will feed electron density into this. But I already have negative charge up here, which means I have extra electrons that I want to stabilize. Well, if I'm feeding in more electron density, that will not stabilize this. I need to pull some away to help delocalize that charge. That's what an electron withdrawing group like this fluorine containing carbon atom will do. And that's why this one is stronger, because it's stabilizing the charge better than its counterpart over here.